Welcome to Unit 5, Lesson 12, the number E practice problems. Okay, so what you're going to do is you're going to put all of these into y equals. Put this one in a y1. I forgot to change the colors here. So let's put this one in a y1, this one in a y2. So black, let's see what are the colors on the calculator? The first one is blue, I'm sorry. The first graph on the calculator is blue. The second color on the graph is red. The third color is black. The fourth color is pink. And I don't have a pink here, so I'll just say red. And Y5 is actually green. And then what you do is put these into the calculator. And what you'll see is E cubed has the highest, it grows the fastest. So basically you're going to get a bunch of lines that look like this and this and this. And some of them, they might be even closer together than that. So E cubed is this one, 2.7 cubed. E to the E is number 2. E to the E. E squared is number 3. And then 2 times E is number 4. That's 2E. And then 2 squared, which is 4, is the last one. It grows the slowest. 2 times 2.7 is 5.4. 2.7 times 2.7. I don't know. 3 times 3 is 9. 2 times 2 is 4. We know it's bigger than 5.4. I'll put it in the calculator and see. But if you just put them all in a y equals and then hit graph, you'll see your calculator give you the graphs. Okay, here are the graphs of 3 functions. How do you know which one is which? Well, this graph 1 is H because 3 is bigger than 2.7. Graph 2 is G, and graph 3 is F. It grows the slowest because E is 2.7, so it's closer to 3 than the 2. Okay, which of the statements are true about the function given by this? So if I stick 0 in, anything to the 0 power that's not 0 is 1. So F, A is true. I can never remember to turn these thing on. A is true. B, the value of F increases when X increases. No, because you have a negative exponent. C, the value when X equals -1 is a little less than 40. That's not true. The value of F when X equals 5 is less than 1. That's true. The value of F is never 0. 0 is an asymptote of an exponential function base E. Okay, suppose you have put $1 in an interest-bearing account for 1 year and are offered different options for interest rates and compounding frequency. How often interest is calculated is shown on the table. The table is on the next page. The highest interest rate is 100%, calculated once a year. The rate is adjusted so that the rate is divided by the frequency per year remains 100%. That's a lot of fancy talk for saying in some exponential equations, especially dealing with money, you look at something like this, 1 over, I think, R to some R times T or N, something like this. It's either RT or RN. I can't remember the equation off the top of my head, but it looks something like this. But since this 1 is 100%, this basically becomes 1 plus 1. And then we're just going to call that X. And basically that's doubling. So This is the continuation of the problem from the previous page. Okay, and how do you get the second number? 1 is 100%. That's your original dollar that you put in. And this is 1 over the interest rate, which is 100%, which is 1. Okay, so if we was to rewrite this one, which one grows the fastest? 1 plus 1 over 0.01. So basically, I calculated it all out. So here's what you get. It seems like this is the best rate, and this is not too far behind. And as you can see, as the exponents get very large, you get close to the number e. So it's about the exponent more than it is about the number in the parentheses, because that's a very small number, but the exponent is so large that that's what happens to your money after a year. The account value will not be greater than 3 because you saw this calculated. The highest it gets is 2.7183 rounded off to 4 decimals. What do you notice about the value of the accounts as the frequency of compounding is larger? So as the frequency of compounding gets larger, it approaches E. The irrational number E. Okay, so if we were to put this into a graph, we would see this figure here. Where this is 1 and this is about E. It's about E. So as X goes to 0, Y approaches E. As X goes to positive infinity, Y approaches 1. Okay, since 1992, the value of homes in the neighborhood has doubled every 16 years. The value of one home in the neighborhood, what was the value of the home in 2000? Well, since 2000 is 8 years away and it's 16, so that gives us 8 out of 16. So we're going to take our original amount, it doubles, that's our rate, to the 1/2, and that gives us approximately $193,040. Write an equation. We should have wrote the equation first. I don't know why they didn't ask us to write the equation. It's 136,500 to the t for 1 year out of every 16. Because that says t years, which means 1 year. But it doubles every... Oh, wait, I forgot to put the rate in there. That would throw us off to the t over 16. Okay, write an equation that represents the value of decades. So 136,500, it doubles 10, and D stands for decade. You need an exponent there to count the number of decades, because if you just put 10, that's only 1 decade. So use one of your equations to find the value of home. So I'm going to use B, and I'm going to put this into the calculator. And 1.5 decades is 15 years out of 16. And we are going to approximate $261,425. Write 2 equations, one in exponential form and one in logarithmic, to write each equation. So 5 5 to what exponent gives us 625? Okay. Now, the base is 5. Log base 5 of 625 equals what? And this is the one we put into the calculator unless we know our exponents of 6. Now, what is the log base 3? 3 to what power equals 27? And we say log base 3 of 27 equals what? So again, when going from exponentials to logs or logs to exponentials, move the exponent and the answer across the equal sign. Okay, Claire says that log of 0.1 equals -1. Kieran says that log -10 equals -1. Do you agree with either one of them? Well, the log of 1/10, Claire, is true. And Kieran, you cannot take the log of a negative number. That will give you an error. So this is an error on a calculator. You don't take logs of negative numbers. It's just not possible.